In the last video, we spent quite a bit of time looking at the derivation of the formula for an ellipse. It is quite a bit of work to do that, but in the end, we come up with this basic formula. We looked at a formula in particular whose major axis was parallel to the x-axis. And we also had the center shifted over to HK, some arbitrary central point. Here I'm just going to have a little discussion of how to change the orientation so that the major axis is now parallel to the y-axis. I'm going to leave the center at 0 for now, and then we'll generalize and show you how to shift everything if we move the center or move the entire ellipse over to a central point of HK again. And so to start off, we said there are really 6 major points to deal with an ellipse. You've got the 2 foci, those are the points on the interior here. Actually 7 because you're the center. The 2 foci, the center, the 2 vertices, which are also on the major axis. And then you have the 2 endpoints of the minor axis. They don't have a nice name, or at least I don't know of one. It's not in the book. Not one that we generally talk about, but they are 2 very important points in order to get the graph of your ellipse. So what we notice, we have for our formula here, the A and B values correspond to the intersection of the graph with its major and minor axes. So the A value, if the graph is oriented with the major axis parallel to the x-axis, so horizontally, laying horizontally, the A value is bigger than B, and the A is going to be underneath the X and the B underneath the Y. Basically what that means is when you have your formula for an ellipse, the number under the X squared will be the bigger one, the number under the Y squared will be the smaller one. Okay, so this could be a 9 and this might be a 4, for instance. And so the bigger one, if the bigger number is under the X squared, that means it lays horizontally. All right. In the case of where it stands up vertically, or has a major axis that is running vertically or parallel to the y-axis, the 2 variable or the 2 constants switch. So basically, the bigger one is now going to be underneath the y, and the smaller one under the x. We always assume that A is bigger than B or greater than B, so the larger one would be under the y, the smaller one under the x. Okay. And now the points here are all related to the A, B, and C values. Also, we had this relationship between the B squared, the A squared, and the C squared. The A values correspond to the coordinates of the vertex, or the vertices, sorry, 2 vertices. So the one on the left here would be at negative A, the one on the right would be at positive A. Technically, those would be ordered pairs, negative A comma 0, positive A comma 0. In fact, I'm going to go ahead and write a list of points here. So vertex 1, I'm going to call it negative A comma 0. Vertex 2, I'll put them both up there. Vertex 2 would be A comma 0. All right. Now the two points that are on the minor axis are given coordinates of B. Okay. So we'd have negative B on the bottom, positive B on top, and those 2 points technically they would be 0 comma negative B and 0 comma B. Right, so those are the 2 points there. Then we have the 2 foci. We'll call them focus 1 and focus 2, and they are given coordinates of C, positive C and negative C. All right, so here's negative C, here's positive C, and of course the first one there is negative C comma 0. The second one is going to be positive C comma 0 if you look at the ordered pairs. All right, and of course the center is at 0, 0 in this particular example. Now if I were to switch the orientation so that the major axis is running vertically, then again the A value, the larger value, goes underneath the y squared, and the smaller value goes underneath the x squared. But the A, B's, and C's correspond to the same points. They're just now in different coordinates. So the vertices, we'll call them V1 down here in the bottom. That's going to be at negative A in the Y direction, and vertex 2 is going to be at positive A in the Y direction. So if I write these out, vertex 1 would be at 0, negative A, and vertex 2 would be at 0, positive A. So the value for A is just going to be in the other coordinate, the Y coordinate now. Similarly for the points on the minor axis, they would be at negative B and positive B. But again, those values are going to be in the Y coordinate. And then the foci are going to be at negative C and positive C. So focus 1 is going to be 0, negative C. Focus 2 is going to be at 0, C. All right? So again, oh, did I do that? You know what I did wrong? This point right here, and this one. I put those B's in the wrong coordinates. Notice the B's are in the X direction. Silly me. So I got to rewrite that. So that's negative B, 0, and B, 0. Did it correctly here. Okay. So the foci and the vertices are in the Y coordinate. The minor axis points are in the X coordinate. That makes sense. Okay? And still, the relationship between those three values can be found using this difference of squares. So a squared minus c squared equals b squared. And that'll work for every ellipse. Now, as soon as I shift the ellipse off of the origin as its central location, we have to add h and k to each of the corresponding coordinates. All right, so if the center is at h, k, then all of these points change. Vertex 1 becomes, well, I got to add h and add k. So it'd be h minus a, k. If that makes sense. If I add h to negative a, it's just h minus a. And then add a k there. Vertex 2 would become h plus a, k. So I'm shifting the y direction vertically k units and the x direction vertically h units. I'm sorry, horizontally h units. These other 2 points, 0, negative b, would become h, k minus b. Right, so I'm just adding in an h and a k there. Similar here, it would become h, k plus b. And for the foci, you would get h minus c, k, and focus 2 is going to be h plus c, k. All right? And I could repeat the process for the other orientation. If I were to have a center at h, k, I didn't really plan the spacing out on this very well, but that's okay. We'll run it down the side here. Vertex 1 becomes h, k minus a. Again, add in h, add in k. Vertex 2 becomes h, k plus a. The point on the minor axis here becomes h minus b, k. That works, right? Yeah. Then this one becomes h plus b, k. And then the 2 foci, focus 1 would become h, k minus c. And focus 2 would become h, k plus c. Okay. There is a couple nice tables in your textbook that summarize this information. You can find that on page 670, and it does give you, may not have all of these coordinates, but it gives you a good chunk of them. and it gives you the formulas. It also shows you the formulas in the shifted version. So this formula here would become x minus h squared over a squared plus y minus k squared over b squared equals 1. And then those just shift over, nothing changes with those. And then the same thing over here, you would end up with x minus h squared over b squared plus y minus k squared over a squared equal to 1. All right, so that gives you your two formulas, and again, these don't change. The inequality and the equation, those shift over and remain the same. All right, so coming up in the next couple videos, we'll go through some examples. When we start plugging in values for A, B, and C, if I give you the equation, you'll then be able to come up with all these points and be able to plot them, all 7 points. In addition, if you're given the graph or given just pieces of information, maybe one vertex and one foci or something like that, you'd be able to come up with all the other pieces, all the other 5 points, and also the equation. So we'll kind of explore those options.